everyone. Let's continue. 1.3. The fourth statement. As you might expect, there are plenty of different ways to write a program. Let's try a variation on the temperature converter. Hang on. Like these words, this snap code, or this snip code. I don't know what does the word spell. I'm sorry. This produces the same answers, but it certainly looks different. What different? Okay, yeah, different. One major change is the elimination. Hang on. I'm sorry. Of most of the variables, only Pharaoh remains, and as int to show the %d conversion in printf, the lower and upper limits and the step size appear only as constants in the for statement. Itself a new construction in the expression that computes the Celsius temperature now appears as the third argument of the printf instead of in a separate assignment statement. This last change is an instance of a quiet general rule in C. In any context where it is permissible to use the value of a variable of some type. Hang on. You can use an expression of that type, since the third argument of the printf has to be a floating point value to match the %6.1f. Any floating point expression can occur there. The for itself is a loop, a generalization of the while. If you compare it to the earlier while, its operation should be clear. It contains three parts separated by semicolons. The first part, for equals 0, is done once before the loop proper is entered. The second part is the text or condition that controls the loop, for less than or equal to 300. This condition is evaluated if it is true. The body of the loop, here is a single printf, is executed. Then the reinitialization step, for equal for plus 20, is done. In the condition re-evaluated, the loop terminates when the condition becomes false. As with the while, the body of the loop can be a single statement or a group of statements enclosed in braces. The initialization and reinitialization parts can be any single expression. The choice between while and for is arbitrary based on what seems clear. Based on what seems clearer. Hang on. The for is usually appropriate for loops in which the initialization and reinitialization are single statements and logically related, since it is more compact than while and keeps the loop control statements together in one place. Exercise 1, mid score 5, modify the temperature conversion program to print the table in reverse order. That is from 300 degrees to 0. 1.4 Symbolic constants. A final observation before we leave temperature conversion forever. It is bad practice to bury magic numbers like 320 in a program. They convey little information to someone who might have to read the program later, and they are hard to change in a systematic way. Fortunately, C provides a way to avoid such magic numbers. With the hash define construction, at the beginning of a program, you can define a symbolic name or symbolic constant to be a particular string of characters. Thereafter, the compiler will replace all unquoted occurrences of the name by the corresponding string. The replacement for the name can actually be any text at all. It is not limited to numbers. The quantities lower, upper, and step are constants. And they do not appear in declarations. Symbolic names are commonly written in uppercase. So they can be readily distinguished from lowercase variable names. Notice that there is no semicolon at the end of a definition, since the whole line after the defined name is substituted. There would be too many semicolons in the for. Substituted. What? Since the whole line after the defined name is substituted, there would be too many semicolons in the for. 1.5 A collection of useful programs. We're now going to consider a family of related programs for doing simple operations on character data. You will find that many programs are just expanded versions of the prototypes that we discuss here. Character input and output. The standard library provides its functions for reading and writing a character at a time. GetChar fetches the next input character each time it is called and returns that character as its value. That is, after C equal getChar parentheses, the variable C contains the next character of input. The characters normally come from the terminal, but that need not concern us until Chapter 7. The function putChar is a complement of getChar. PutChar parentheses C prints the contents of variable C on some output medium. Again, usually the terminal. Hang on. Calls to a putChar and printf may be interleaved. The output will appear in the order in which the calls are made. As with printf, there is nothing special about getChar and putChar. They are not part of the C language, but they are universally available. File copying. Given getChar and putChar, you can write a surprising amount of useful code without knowing anything more about I/O. The simplest example is a program which copies its input to its output one character at a time. In outline, getChar while parentheses character is not end of file signal. Output the character just read get a new character. Converting this into C gives main parentheses / copy input to output semicolon first version * braces int C semicolon C equal getChar parentheses semicolon while parentheses C exclusive equal EOF parentheses putChar parentheses C semicolon C equal getChar parentheses semicolon. The relational operator exclusive equal means not equal to. The main problem is detecting the end of the input. By convention, getChar returns a value which is not a valid character when it encounters the end of the input. In this way, programs can detect when they ran out of input. Hang on. The only complication is serious license is that there are two conventions in common use about what the end of file value really is. We have different We have differentiated the issue by using the symbolic name EOF for the value, whatever it might be. In practice, EOF will be either -1 or 0, so the program must be preceded by the appropriate one of. In order to work properly, okay, hang on. In order to work properly by using the symbolic constant EOF to represent the value that getChar returns when end of file occurs, we are assured that only one thing in the program depends on the specific numeric value. We also declare C to be an int, not a char, so it can hold the value which getChar returns, as we shall see in Chapter 2. This value is actually an int, since it must be capable of representing EOF in addition to all possible chars. The program for copying would actually be written more concisely by experienced C programmers. You see, any assignment such as C equal to getChar parentheses can be used in an expression. Its value is simply the value being assigned to the left-hand side if the assignment of a character to C is put inside the test part of a while. The file copy program can be written like these words, like this sentence. The program gets a character assigns to C and then tests whether the character was the end of file signal. And then tests whether the character was the end of file signal. If it was not, the body of the while is executed, printing the character. The while then repeats. When the end of input is finally reached, the while terminates, and so does main. The function centralizes the input. There's now only hang on. There's now only one core to getChar and shrinks the program. Nesting an assignment in a test is one of the places where C permits a valuable conciseness. It is possible to get carried away and create impenetrable code, though a tendency that we will try to curb. It is important to recognize that the parentheses around the assignment within the conditional are really necessary. The precedence of exclusive equal Here, of exclusive equal is higher than that of equal, which means that in the absence of parentheses, the relational test exclusive equal would be done before the assignment equal. So the statement C equal get char parentheses exclusive equal EOF is equivalent is equivalent is equivalent here is equivalent to C equal parentheses get char parentheses exclusive equal EOF. This has the undesired effect of setting C to 0 or 1, depending on whether or not the call of getchar encountered end of file. More on this in Chapter 2. Character counting. The next program counts characters. It is a small elaboration of the copy program. Like these words, the statement plus plus and C parentheses semicolon shows a new operator plus plus, which means increment by 1. Here, you could write NC equal NC plus 1, but plus plus NC is more concise and often more efficient. There is a corresponding operator minus minus to decrement by 1. The operator plus plus and minus minus can be either prefix operators or postfix. These two forms have different values in expressions, as will be shown in Chapter 2, but plus plus NC and NC plus plus both increment NC. For the moment, we will stick to prefix. The character counting program accumulates its count in a long variable instead of in an int. On a PDP-11, the maximum value of an int is 32767, and it will take relatively little input to overflow the counter if it were declared int. In Honeywell and IBM C, long and int are synonyms and much larger. The conversion specification person1d signals to print f that its corresponding argument is a long integer. No, this is not 1d. This is person ld. How do I distinguish L and 1? How do I tell the letter L and the number 1? That is L. I'm absolutely sure %LD signals to printf that the corresponding argument is a long integer. Okay, got it. To cope with even bigger numbers, you can use a double length float. We will also use a for statement instead of a while to illustrate an alternative way to write the loop. Like these words, printf uses %f for both float and double. %.0f suppresses printing of the non-existent fraction part. The body of the for loop here is empty because all of the work is done in the test and reinitialization parts, but the grammatical rules of C require that a for statement have a body. The isolated semicolon, technically a null statement, is there to satisfy that requirement. We put it on a separate line to make it more visible. Before we leave the character counting program, observe that if the input contains no characters, the while or for test files on the very first call to get char, and so the program produces 0. The right answer. This is an important observation. One of the nice things about while and for is that the test at the top of the loop before proceeding with the body. If there's nothing to do, nothing is done, even if that means never going through the loop body. Programs should act intelligently. One-handed input like no characters. The while and for statements help ensure that they do reasonable things with boundary conditions. Live counting. The next program counts lines, and its input lines are assumed to be terminated by the new line character \n that has been religiously appended to every line reading out. I'm sorry. Okay, sorry. Hang on. I have to do some. Okay. Like these words, the body of the while now consists of an if, which in turn controls the increment ++n L or 1. I'm so confused. Okay, what the hell? The if statement tests the parenthesized condition, and if it is true that the statement or group of statements embraces that follows, we have again indented to show what is controlled by what. The double equals sign equal is the C notation for is equal to. Like for instance, EQ, uppercase EQ. This symbol is used to distinguish the quality test from the single equal used for assignment. Since the assignment is about twice as frequent as quality testing in typical C programs, it's appropriate that the operator be half as long. Any single character can be written between single quotes to produce a value equal to the numerical value of the character in the machine's character set. This is called a character constant. So, for example, single quote uppercase A is a character constant, and the ASCII character set its value is 65. The internal representation of the character uppercase A, of course, single quote uppercase A is to be preferred over 65. Its meaning is obvious, and it is independent of a particular character set. The escape sequences used in character strings are also legal in character constants. So in text and arithmetic expressions, single quote \n stands for the value of the new line character. You should note carefully that single quote \n is a single character, and in expressions is equivalent to a single integer. On the other hand, double quote \n is a character string which happens to contain only one character. The topic of strings versus characters is discussed further in Chapter 2. Exercise 1-6. Write a program to count blanks, tabs, and new lines. Exercise 1-7. Write a program to copy its input to its output, replacing each string of one or more blanks by a single blank. Exercise 1-8. Write a program to replace each tab by the 3-character sequence greater than backspace, which prints as arrow, and each backspace by the similar sequence backward arrow. This makes tabs and backspaces visible. Word counting. The fourth in our series of useful programs counts lines, words, and characters, with the loose definition that a word is any sequence of characters that does not contain a blank tab or new line. This is a bare bones version of the Unix Autodidactism WC. Okay, like these words. Every time the program encounters the first character of a word, it counts it. The variable inward records whether the program is currently in a word or not. Initially, it is not in a word, which is assigned the value number or no. We prefer We prefer the symbolic constants yes and no to the literal values 1 and 0 because they make the program more readable. Of course, in a program as tiny as this, it makes little difference, but in larger programs, the increase in clarity is well worth the modest extra effort to write it this way originally. You will also find that it's easier to make extensive changes in programs where numbers appear only as symbolic constants. Hang on. Okay. A line NL equal NW equal NC sets all three variables to 0. This is not a special case, but a consequence of the fact that an assignment has a value and assignments associate right to left. It's really as if we had written the operator bar means or. So the line says if C is a blank or C is a new line or C is a tab, the escape sequence \t is a visual representation of the tab character. There is a corresponding operator %% for n, ampersand for n. Expressions connected by ampersand or bar are evaluated left to right, and it is guaranteed that evaluation will stop as soon as the truth or falsehood is known. Thus, if C contains a blank, there is no need to test whether it contains a new line or tab, so these tests are not made. This isn't particularly important here, but is very significant in more complicated situations, as we will soon see. The example also shows the C-else statement, which specifies an alternative action to be done if the condition part of an if statement is false. The general form is one and only one of the two statements associated with an if-else is done. If the expression is true, statement 1 is executed. If not, statement 2 is executed. Each statement can in fact be quite complicated. In the word count program, the one after the else is an if that controls two statement embraces. Exercise 1 middle score 9. How would you test the word count program? What are some boundaries? Exercise 1 middle score 10. Write a program which prints the words in its input 1 per line. Exercise 1 middle score 11. Revise the word count program to use a better definition of word. For example, a sequence of letters, digits, and apostrophes that begins with a letter. 1.6 Erase. Let us write a program to count the number of occurrences of each digit of white space characters, blank tab, new line, and all other characters. This is artificial, of course, but it permits us to illustrate several aspects of C in one program. There are 12 categories of input, so it is convenient to use an array to hold the number of occurrences of each digit. Rather than 10 individual variables, here is one version of the program. Declares n digit to be an array of 10 integers. Array subscripts always start at 0 in C rather than 1 as in Fortran or PL snapshot. Hang on. So the elements are n digit break is 0, n digit break is 1 until n digit break is 9. This is reflected in the for loops which initialize and print the array. A subscript can be any integer expression, which of course includes integer variables like I and integer constants. This particular program relies heavily on the properties of the character representation of the digits. For example, the test determines whether the character in C is a digit. If it is, the numeric value of that digit is. This works only if single quote 0, single quote 1, etc. are positive and in increasing order, and if there is nothing but digits between single quote 0 and single quote 9. Fortunately, this is true for all conventional character sets. By definition, arithmetic involving chars and ends converts everything to end before proceeding. So chars variables and constants are essentially identical to ends in arithmetic contexts. This is quite natural and convenient. For example, C middle score single quote 0 is an integer expression with a value between 0 and 9 corresponding to the character single quote 0 to single quote 9 stored in C and is thus a valid subscript for the array n digit. The decision as to whether a character is a digit, a white space, or something else is made with the sequence pattern. Occurs frequently in programs as a way to express a multi-way decision. The code is simply read from the top until some condition is satisfied. At that point, the corresponding statement part is executed, and the entire construction is finished. Of course, statement can be several statements enclosed in braces. If none of the conditions is satisfied, the statement after the final else is executed if it is present, if the final else and statement are omitted. As in the word count program, no action takes place. There can be an arbitrary number of groups between the initial if and the final else. As a matter of style, it is advisable to format this construction as we have shown, so that long decisions do not march off the right side of the page. The switch statement to be discussed in Chapter 3 provides another way to write multi-way branch that is particularly suitable when the condition being tested is simply whether some integer or character expression matches one of a set of constants. For contrast, we will present a switch version of this program in Chapter 3. Exercise 1, middle score 12. Write a program to print a histogram of the length of words in its input. It is easiest to draw the histogram horizontally. A vertical orientation is more challenging. (1.7) Functions. In C, a function is equivalent to a subroutine or function in Fortran, or a procedure in Pascal. Etc. A function provides a convenient way to encapsulate some computation in a black box, which can then be used without worrying about its innards. Functions are really the only way to cope with the potential complexity of large programs. With properly designed functions, it is possible to ignore how a job is done. Knowing what is done is sufficient. C is designed to make the use of functions easy. Yeah. Convenient and efficient. You will often see a function only a few lines long called only once, just because it clarifies some piece of code. So far we have used only one functions like printf, getChar, and putChar that have been provided for us. Now it is time to write a few of our own. Since C has no exponentiation operator like the asterisk of Fortran or PS-i, let us illustrate the mechanics of function definition by writing a function power parenthesis m comma n to rise an integer m to a positive integer power n, that is the value of power parenthesis 2 comma 5 is 32. This function certainly doesn't do the whole job of asterisk since it handles only positive powers of small integers, but it's best to confuse only one issue at a time. Here is the function power and a main program to exercise it, so you can see the whole structure at once. Each function has the same form. The functions can appear in either order, and in one source file or in two. Of course, if the source appears in two files, you will have to say more to compile and load it than if it all appears in one, but that is an operating system matter, not a language attribute. For the moment, we will assume that both functions are in the same file, so whatever you have learned about running C programs will not change. The function power is called twice in the line. Each OR passes two arguments to power, which each time returns an integer to be formatted and printed. In an expression, power parenthesis 2 comma I is an integer just as 2 and I are. Not all functions produce an integer value. We will take this up in Chapter 4. Impart the arguments. To be declared appropriately, so their types are known. This is done by line. That follows the function name. The argument declarations go between the argument list and the operating left brace. Each declaration is terminated by a semicolon. The names used by Power for its argument are purely local to Power and not accessible to any other function. Other routines can use the same names without conflict. This is also true of the variables I and p. The I in Power is unrelated to the I in main. The value that Power computes is returned to main by the return statement, which is just as in pl/i. Any expression may occur within the parentheses. A function need not return a value. A return statement with no expression causes control, but no useful value to be returned to the caller, as does failing of the end of a function by reaching the terminating right brace. Exercise 1 middle score 13. Write a program to convert its input to lowercase using a function lower, which returns C if C is not a letter, and the lowercase value of C if it is a letter. 1.8 Arguments called by value. One aspect of C functions may be unfamiliar to programmers who are used to other languages, particularly Fortran and pl/i. In C, all function arguments are passed by value. This means that the called function is given the value of its arguments in temporary variables, actually on a stack, rather than their addresses. This leads to some different properties than are seen with call by reference languages like Fortran and pl/i, in which the called routine is handed the address of the argument, not its value. The main distinction is that in C, the called function cannot alter a variable in the calling function. It can only alter its private temporary copy. Call by value is an asset. However, not a liability. It usually leads to more compact programs with fewer extraneous variables, because arguments can be treated as as conveniently initialized local variables in the code routine. For example, here is a version of power which makes use of this fact. The argument n is used as a temporary variable and is counted down until it becomes 0. There's no longer a need for the variable I. Whatever is done to n inside power has no effect on the argument that power was originally called with. When necessary, it is possible to arrange for a function to modify a variable in a calling routine. The caller must provide the address of the variable to be set, technically a pointer to the variable, and the called function must declare the argument to be a pointer and reference the actual variable indirectly through it. We will cover this in detail in Chapter 5. The name of an array is used as an argument. The variable passed to the function is actually the location of address of the beginning of the array. There's no copying of array elements. By subscripting this value, the function can access and alter any element of the array. This is the topic of the next section. 1.9 Character arrays. Probably the most common type of arrays in C. Probably the most common type of array in C is the array of characters. To illustrate the use of character arrays and functions to manipulate them, let's write a program which reads a set of lines and prints the longest. The basic outline is simple enough. This outline makes it clear that the program divides naturally into pieces. One piece gets a new line, another tests it, another saves it, and the rest controls the process. Since things divide so nicely, it would be well to write them that way too. Accordingly, let us first write a separate function getLine to fetch the next line of input. This is a generalization of getChar. To make the function useful in other contexts, we will try to make it as flexible as possible. Hang on. At the minimum, getLine has to return a signal about possible end of file. A more general useful design would be to return the length of the line or 0 if end of files is encountered. 0 is never a valid line length, since every line has at least one character. Even a line containing only a low line has length 1. When we find a line that is longer than the previous longest, it must be saved somewhere. This suggests a second function copy to copy the new line to a safe place. Finally, we need a main program to control getLine and copy. Here is the result. Okay, everyone, it is time for me to take a short break. See you.